Vaccines work to prime your immune system against future attacks by a particular disease. There are vaccines against both viral and bacterial pathogens or disease-causing agents. When a pathogen enters your body, your immune system generates antibodies to try to fight it off. Depending on the strength of your immune system and how effectively the antibodies fight off the pathogen, you may or may not get sick. If you do fall ill, however, some of the antibodies that are created will remain in your body playing watchdog after you're no longer sick. If you're exposed to the same pathogen in the future, the antibodies will recognize it and fight it off.
Vaccines are designed to generate an immune response that will protect the vaccinated individual during future exposures to the disease. Individual immune systems, however, are different enough that in some cases a person's immune system will not generate an adequate response. As a result, he or she will not be effectively protected after immunization. That said, the effectiveness of most vaccines is high. After receiving the second dose of the MMR vaccine, measles, mumps, and rubella, or the standalone measles vaccine, 99.7% of vaccinated individuals are immune to measles. The inactivated polio vaccine offers 99% effectiveness after 3 doses. The varicella or chickenpox vaccine is between 85 and 90% effective in preventing all varicella infections, but 100% effective in preventing moderate and severe chickenpox.
Herd immunity, also known as community immunity, refers to the protection offered to everyone in a community by high vaccination rates. With enough people immunized against a given disease, it's difficult for the disease to gain a foothold in the community. This offers some protection to those who are unable to receive vaccinations, including newborns and individuals with chronic illnesses. By reducing the likelihood of an outbreak, this could expose them to the disease.
In some cases, natural immunity is longer lasting than the immunity gained from vaccination. The risk of a natural infection, however, outweigh the risk of immunization for every recommended vaccine. For example, wild measles infection causes encephalitis, which is inflammation of the brain, for 1 in 1,000 infected individuals. Overall, measles infection kills 2 of every 1,000 infected individuals. In contrast, the combination MMR, which is measles, mumps, and rubella, vaccine results in a severe allergic reaction only once in every million vaccinated individuals while preventing measles infection. The benefits of vaccine-acquired immunity extraordinarily outweigh the serious risk of natural infection.
Studies demonstrate that infants' immune systems can handle receiving many vaccines at once, more than the number currently recommended. The immunization schedule is based on infants' ability to generate immune responses, as well as when they are at risk for a certain illness. For example, the immunity passed from mother to child at birth is only temporary and typically does not include immunity against polio, hepatitis B, hemophilus, influenza type B, and other diseases that can be prevented by vaccination.
Unlike most vaccines, which contain the most common strains of a given pathogen and are rarely changed, the seasonal flu vaccine changes frequently, though 1 or more of the flu strains in the vaccine may be retained from 1 year to the next. This is because the strains of influenza viruses that circulate are constantly changing. Each year, researchers choose viruses for the vaccine based on which ones are likely to be circulating over the course of the coming flu season, thus providing protection against the most prevalent strains. So when you get a seasonal flu vaccine, you're usually not getting another dose of the same flu vaccine you were given before. Instead, you're usually getting protection against a whole new batch of flu viruses.
No, vaccines do not cause autism. The possibility was publicized after a 1998 paper by a British physician who claimed to have found evidence that the MMR vaccine was linked to autism. The potential link has been thoroughly explored. Study after study has found no such link, and the original 1998 study has been formally withdrawn by The Lancet, which was originally published it. Studies were also done regarding the possibility of a link between the preservative thimerosal, which is used in some vaccines, and autism. Again, no such link has been found. It's likely that the misconception persists because the coincidence of timing between early childhood vaccinations and the first appearance of symptoms of autism.